LessWrong posts.
I found these two interesting because at first when I was reading them, I'm like, why all this math? What does this have to do with Human's Guide to Words? But like then when we get to the end, there's a massive payoff. And I was like, oh, okay, yeah, this totally made sense.
That was my exact experience reading them as well. I think, Yudkowsky's reading math books since, I think he's single-digit years of age. So I think he typical minds a little bit on how much the rest of us enjoy math. But that said, it's not like this is exactly hard to follow, and it's not valuable. But you can be darn sure that I've never calculated entropy, with binary code. Nor will I probably ever. But now I know that I can if I ever need to.
I think it may be less typical minding and more aiming for a specific audience.
Yeah, that makes sense. Still, I'd like to feel included. So,
I mean, we can look in from the outskirts.
Yeah, that's true. We're not mathematicians, but it's not just mathematicians.
Yeah, sometimes we play ones on TV, and that's close enough.
Right.
So entropy and short codes starts out with postulating a system X that has 8 possible states that are equally likely, and introduces a definition of entropy, which was new to me. I don't know where this comes from specifically, but entropy of this system is 3 bits, which means that on average, we have to ask 3 yes or no questions to find out X's value.
Yeah, the use of the word entropy, I'm sure, is technically correct, because I can't point to an example where Yudkowsky ever has something written here that is technically incorrect.
Yeah, like in some math way.
Right, exactly. But I've never come across this use of entropy elsewhere in my life. Usually it's meant to just be, well, I guess it is a measure of the disorder in a system, which if you squint, you can make more orderly by learning more about it. So, yeah, it's just I never usually hear it talked about that way.
But basically, when the 8 possible states are all equally likely, with each yes or no question, you can eliminate half of them, which is how it takes 3 bits to get to the answer that you want.
Right.
Then he says, suppose a system Y that has 4 possible states, but they aren't all equally likely. The first one is 50% likely, the next one 25%, and then the last 2 are both 12.5% likely. He says that the entropy of Y would be 1.75 bits, meaning that we can find out the value by asking 1.75 yes or no questions, and then goes on to describe what this means. Since the first option is 50%, you can get rid of 50% of the entropy with a single question that will eliminate the other 3 answers if number 1 is yes. So half the time, you only have to ask 1 question. And then 25% of the time, you can ask 2 questions to locate the answer that you want. And then the other 25% of the time, you have to ask a 3rd question to differentiate between the last 2 states. So on average, it all comes out to 1.75 questions that you have to ask if you have to repeatedly query this sort of system.
Right. This is one of those cases where, I'm glad I read the post rather than listen to it. Because these ones this is hardly like one of the mathiest ones, but the mathier ones are hard to listen to. Having the little chart, what do you call that? Infographic? I don't know. 2-line Excel spreadsheet. Really helps pin this out because my first thought is, how do I ask 0.75 of a question? What is 3/4 of a bit? But no, he's saying on average, and that makes sense. And then when he's talking about code transmission, as compactly as possible. I'm like, oh, I see where this is going now. Okay, gotcha. The point is that you reserve short words for things that you'll need to say frequently and longer words for things that you won't need to say as often.
Right, because you got to assign a code to each possibility. You assign the short codes to the ones that happen most often because that helps to differentiate them from the more uncommon ones easily. You can more quickly distinguish them than by using a short code for all of them, which, boils down to the words thing, as you just said.
Yeah.
I thought one of the interesting points to all this is that when he says, when you take this art to its limit, the length of the message you need to describe something corresponds exactly or almost exactly to its probability, which is kind of neat.
I'm going to just take his word for that. So I think he fleshes that out a bit more in the next post. I didn't spend any time trying to think of counterexamples where and I think he talks about it too, is that's a formalization of Occam's razor. Part of what it means to be parsimonious with your explanation is that you're not introducing a bunch of extra information. And the more extra information you do introduce, the less likely it is.
Right.
Try to explain everything we observe in the sky with the observation of the planets wandering and stuff. You've got to really, really squint and make a lot of confusing inferences. Or you can just say, oh, it looks like we all go around the sun, actually. And that explains it perfectly.
Yeah.
That's a good example.
It is. When I was reading this, it totally reminded me of when we were reading Plane Crash.
Yes.
And they're very frequently going back to very large concepts having very short words, because apparently, like in Dot the Law, people just use these concepts so freaking often. The frequency of how often you run into it is directly proportional to how short the word is.
I think we did talk about that, and that was probably mentioned in the book too.
Well, then good. We're good readers.
Well, no, I mean, well, and, it was a while ago, but I think that was one of the things that Keltham lamented a lot, was like, oh, you guys don't have a word for this. Okay, well, then we'll use these long words for it. So I think that was kind of like an explicit criticism of his, is that this language doesn't seem like it's designed in a way that makes the kinds of conversations he's trying to have easy.
And that these concepts simply aren't used by these people very often, which probably was insane making for him, because he'd be like, these are the most fundamental concepts for thinking sanely about the world.
Right.
How can you just not use them?
I'm sure there's a 3-syllable word for, basic level categories having short names. That is actually 2 concepts. Basic level categories is probably a single-syllable word.
Yes. Yeah, then that was the thing pulled out near the end there, that basic level categories in our language tend to have very short names, and nouns with short names tend to refer to basic level categories.
Chair versus recliner versus furniture, etc.
Yeah. I also pulled out this one thing where he points out that I can define a word any way I like obstructs the art of carving reality at its joints, and likewise, the sensible sounding, the labels we attach to words are arbitrary, obstructs awareness of compactness, which we get more detail about that in the next post.
Yeah, I liked the ending of this post. Has a fun, a lot of them have fun little last closing zingers. Or, as Douglas Hofstadter put it, there's a reason why the English language uses "the" to mean "the," and anti-disestablishmentarianism to mean anti-disestablishmentarianism instead of anti-disestablishmentarianism other way around.
Yes.
The fact that I stumbled over that, I'm going to go ahead and just own, because that word's long and complicated on purpose. I believe it is the longest word in the language, right?
Oh, I have no idea.
I think it's the longest word in English. I think that's why he used it.
Ah, okay, cool.
And I'm running a quick science here, or I guess you can call it that, to test the idea that common words are short in other language, or like in language on purpose. Skimming across 15 or so just now, the word water looks like it's 1 or 2 syllables in all the languages that have letters that I can read, which is pretty cool, because water is a thing, every language would want to be able to talk about. Oh yeah, and if I look at some of the ones that are using non-English or Roman letters, it actually gives me the English pronunciation underneath it. Mm-hmm. So let me find one here. Let's look at Japanese. Mizu. All right, yeah. So 1 or 2 syllables, it seems like, for everyone that I checked.
Mm-hmm.
That's kind of cool.
That is, yeah. I'm sure there's got to be outliers, and it would be interesting to find out what those exceptions are and why they are.
Yeah, when I live forever, I'll get super into learning languages and learning about them, just because it is fascinating.
Yeah. But we are not living forever today, so not today.
Not today, unfortunately. We've got to talk about mutual information and density in Thingspace.
Yeah! All right, so we were talking about single systems before. What if you got 2 systems? Like X has 8 states, Y has 4 states. What's the entropy of the combined system X and Y? Basically,
are they related or not? First question, right?
There we go, yeah. You would assume 5, but if they're entangled in some way, we're learning something about Y tells us something about X, then you can do it with less bits. He supposes that if, for example, like if both X and Y are either both odd or both even, then you can do it with 4 instead of 5.
Right.
So basically, there is 1 bit of mutual information between those 2 systems. Learning what X is gives us 1 bit of information about Y. We boil down a little bit. After you learn Z, your beliefs about Y is just what it was before, is equivalent to saying that learning about Y never tells you anything about Z, or vice versa. And so there's no mutual information between Y and Z, and where there's no mutual information, there is no Bayesian evidence, and vice versa.
Right.
We're getting into that because if there is an unusually high probability of Z plus Y, defined as a probability that's higher than the marginal probabilities would indicate by default, it follows that observing Y is evidence that increases the probability of Z, and symmetrically, observing Z must favor Y.
Yeah, I mean, it's a fun example today. Like the sun out is evidence that it's warm out, right?
Mm-hmm.
It turns out today the sun just came out like half an hour ago, and it's still 20 degrees, but it's still positive evidence, right?
Yeah.
The snow on the ground is strong counter evidence.
Yes. The reason he brings up all these entangled things is because as we go back to words now, the question comes back to, like, why do you want a word for human? He pulls back to a few earlier episodes where we defined human as a mortal, featherless biped. Why not just say mortal, featherless biped all the time? And part of it is because it's helpful to have shorter words for things that you encounter often. But if your code for describing these things is efficient, there wouldn't be a special advantage to having a special word for a combination like that, unless it's more likely for the combination of mortal and featherless and biped to be more common in combination than you would expect just from those things separately.
Yeah. Mortal, featherless biped is a whole 5 syllables longer, and as we're coming to articulate with I guess mathematical proof, that's no coincidence, right?
Yeah and since he's saying that, like, if you observe y when they're entangled, if you observe y, that increases the probability of z. If a word is a good word like human, then that means that if you observe featherless biped, that increases the probability that it will also be mortal. And that is where there's real utility in having words like this. That having a word for a thing rather than just listing its properties is a more compact code precisely in those cases where we can infer some of those properties from the other properties.
So I think this actually is the sentence that, because I always try to, going through these, doing these segments here, I'm always trying to zoom out and wonder, why is he writing this post? Because, I totally understood the human use of language sequence. It's important to know what the hell we're talking about, right? And no, you can't just use whatever words you want if we're all going to play on the same game, etc. But why talk about short distances or short communication lengths here? And I think that is part of it, because I mean, not saying to define any word you like, but it's like it's helpful to have these shorthands. And so if we want to use a loaded word like intelligence, if we all kind of know what that means, it saves a lot of trouble than just trying to describe all the capabilities of ChatGPT.
Yeah.
You think that I'm on the right track there?
I do think you're on the right track.
Right.
I think the payload that we're about to get to right here is the thing that really made me have a whoa moment.
All right, let's do it.
All right, so he says, so having a word Wiggin for green-eyed, black-haired people, as we discussed, I think, 3 or 4 episodes ago in the LessWrong sequences there, is more useful than just saying green-eyed black people precisely
black-haired people.
Oh, was I saying just black people?
The second time you did.
Sorry.
No, you're good.
It's more useful than just saying green-eyed, black-haired people, precisely when green-eyed people are more likely than average to be black-haired, and vice versa, or Wiggins share other properties that can be inferred at greater than default probability. And the example he used was really liking ketchup. Which means, like, here's the big one may even consider the act of defining a word as a promise to this effect. It asserts that the word Wiggin will somehow help you make inferences and shorten your messages. If it is not the case that the word Wiggin will do this, then the word Wiggin is a lie. The word claims that certain people are worth distinguishing as a group, but they're not.
Yeah,
that's fascinating.
I like that. And it's there. We've talked a lot about like what a group even means with edge cases and exceptions and stuff like that. But this is the kind of payoff of like if you're going to make up whatever a new term for, I don't know, an existent group of people or something, if it's not providing any new information, then it is kind of pointless, right?
Yeah.
I'm sure this actually works great when when a country's at conflict and you name the other group of people that you're fighting something, whatever it is, right?
Right.
So it's like unless that gives us some sort of information, then it's not really helpful. In fact, it's counter helpful because you're acting like you're giving us more information, but you're not.
Yeah.
In fact, you're giving us less because Wiggin doesn't mean anything unless in this case it means green-eyed, black-haired person. If you're not actually describing something worth describing, you're giving us less than you would have if you'd just given us the long description of it.
Yeah, because you made a promise to us and that promise was not fulfilled.
Yeah.
That was a cool ass insight to me. The last thing I have here at the bottom is the way to carve reality at its joints is to draw your boundaries around concentrations of unusually high probability density in Thingspace. Just good advice.
Yeah, no, I like it. I always liked once it painted the picture for me whenever these ages ago was the mental picture of Thingspace. I picture basically like the universe, with clusters and galaxies and whatever. And the more you zoom in, the closer you are to, picking out like this particular couch. you know, which is somewhere in the chair cluster, which is somewhere in the furniture cluster, which is somewhere in the solid objects you put in your house cluster, etc.
Yeah.
Kind of fun.
Well, Stephen, what are we reading for next time?
Next time, we're doing the Superexponential Conceptspace and Simple Words. Superexponential Conceptspace is not simple words. I'm interested to see where that one goes. And this one, I do remember, one of my favorites, Leave a Line of Retreat.